So, in the last class, we have discussed about the linear regression, and then theoretically, we discuss only the linear regression. Today, we will see how the linear regression works, and we will see the coding part of it. Right. So, we will proceed to for the coding part of the linear regression. Is it visible?
Yes, sir.
So this is a Google Colab environment, and here we will code linear regression. So this is the environment where the file, edit, view, and insert tools. These are the basically given over here, and we will code over here, and we will see the code. We will uh, in this is basically the editor view where we will code these things. We will code line by line, and after coding we will run this one. So this is a running cell, right? We will run this and we will see the output. So we will first import. We will first here in the machine learning, we will import the two libraries. One is the NumPy, another is Pandas. And the NumPy is used for, we know that the NumPy is used for NumPy arrays, and we will also import the pandas for data frame for retrieving the data, and these pandas libraries are used. So we will use these two libraries for every machine learning coding part, right? So these two libraries will be imported for every machine learning when we want to code any part, any machine learning. So we will always use these two libraries, NumPy and Pandas. So we will import from this as these are embedded in the Python, and we will import it from that particular library from the Python, and we will include in this environment. So we will see import NumPy as np. Then we will write import pandas as then for graphical application we will import matplotlib or pyplot as plt. from Google Colab import uploaded upload equal to file dot up use the file. And we will write df equal to pd dot double quote, we will write pd sorry, it's an Excel file. So that we will write df dot head now. This is from Google Colab. In the Google Colab environment, uh, this from Google Colab import files. I'm importing the file. Which file that I want to upload? That file should be uploaded over here. That is from the that Excel file is imported and it is uploaded in this environment. So I am importing the file and then I am uploading that file within this environment. So that is why I'm writing over here from google.colab import files and upload files dot upload. So I'm using a function upload over here for uploading the files, and this file is an Excel file, right? If I want to upload the Excel file, so I will choose the file from where it is located. It may be located in desktop or my documents. From there I am just choosing the file and it will be uploaded in this environment. And that particular file, this is basically the uploading file DB. This is the Excel file. So I am doing linear regression, right? So this is predictor value and this is target value. So in if I see the coding part, so pandas PD, the pandas will read this file. What file? The Excel file, which has an extension of .xlsx, right? So this is basically a data frame. So that is why I'm writing over here df is equal to pd, the pandas. Panda will read this file, this Excel file, which was uploaded over in this environment. So that is why I'm writing pd.read Excel. Then I am giving the file name with the extension that is stored in data frame. Now head df.head, if I this head function is used, it will just give by default the first 5 values of the data frame. If I write a df.head, this head function from the data frame will read by default the first 5 values. Similarly, I can write, if I want to see the first 10 values, then I will see df.head the first 10 values. Similarly, we can write the last 5 values. So I will write df.tail. I will see the last 5 values. The last 5 values will be displayed over here from the data frame. Understood? After this,
Sir, can you please provide this Excel file?
yes, I can. This Excel file, here I'm writing Excel file. You can also upload to the CSV file also. Right. You can also upload the CSV file. You can convert this Excel file to CSV file, and also you can upload this. Okay. So any problem up to this? Anybody has any problem? Sorry. Now, I see the column of the data frame here. Column. The column of the data frame will be displayed. So there are 2 columns, hours and scores. These are displayed over here. Right. and they are taking the data frame as an object. That is why they're writing over here. The type is object. ELT dot scatter here hours here course. So this is a scatter diagram of with respect to the hours and scores. That is with respect to the data frame. With respect to the data from the data which was provided to me, with respect to that, the data are scattered in this manner with hours and scores. Right. So these are basically the hour and these are basically the scores. With respect to that, X and Y, the data are scattered over here. This is a scatter diagram of the data which was given to me. Now, if I want to get more information about the data frame, that is what was the data type, column name, and the index number. So that I from the data frame, if I want to get those information, so I will write df dot info will get those information. So these are the index numbers 0 and 1, the column value, the column name, hours and scores, the non-null values, the count, and the data types which are used over here, which are float and integers. Float and integers, the data type, column name, and the index values. Right. So the index value of hour is 0 and the index value of the score is 1. So this is 0, this is 1. Right. If I say df dot describe then this description gives the statistical description, right? Count, mean, standard deviation, that is the mean value, standard deviation values, minimum values, maximum values. Right. So we know that the standard deviation is the difference from the mean value. That is the standard deviation. In statistics, the root of the variance is called the standard deviation. the this maximum values with respect to hours, the maximum values and the minimum values. And this is a minimum value. This is a minimum values, and with respect to minimum value, the score is 21, and with the maximum value of hour, the maximum score is 94. So this is the maximum value. This is minimum value with respect to hours. The minimum value of score with respect to hours. The maximum value of score with respect to hours. So this is the mean value with respect to hours. The mean value of the score is 49.88, and with respect to hours, the count value is 25. The standard deviation is also calculated, and that is the root of variance. The standard deviation is calculated. Now these parameters I will explain later. These parameters. Any question? Any problem? Any problem regarding this? Up to this?
No, sir.
Now for preparing the data, we will see next step is x equal to data frame df dot ilog ilog considering the total column values, considering the total column starting with 0, starting with the 0 columns dot values. See. So this is the x column starting with 2.5, right? So this is showing over here in the form of the arrays because I'm imported the value, the numpy library from the Python, and I'm importing that particular library into this environment. So it is showing in the form of arrays. That is why it is showing in the form of array. Now, df, that is the data frame I'm using over here. This is the data frame df dot ilog. Ilog is a function which is used in Python, and for taking the consideration of the whole column values. When I'm using this double dot, it takes the consideration of the total column values, all the values, starting with a comma, starting with the 0. So starting with 0, all the values. That is why I'm writing total column values. That is why I'm writing over here dot, double dot, and that is it takes the consideration of the total values, all the values, comma, starting with 0, and I am enclosing with these with the third bracket dot. I am using the property values because I want to import, I want to see all the values of the X column. That is why I'm using dot, uh, the value property. I'm accessing the value property with this dot operators. So that is why I'm writing data frame dot ilog, which is a function of Python for displaying all the values, taking consideration of all the values, comma, starting with 0, dot, these are basically the values, so I'm using the property values. So df variable df dot function name dot property. After that, I want to show the x values, all the values of the x column. So this is displayed in the form of array as it is, as I'm importing the library numpy over here. So the values will be displayed in the form of array. So this is for the x column. Similarly, for y column, y is equal to df dot ilog taking consideration of the whole values, first column dot the values. So this is these are basically the predicted value, and these are basically the targeted value. So these are basically the hours, these are basically the scores. So I'm using only one predictor variable and one target variable since I'm doing the linear regression. So in linear regression, there is always be a one one predictor value and one target value. So this is for the predictor variable, this is the target variable. For y column, the y is basically the target variable. X is basically the predictor variable. So df dot ilog, again I'm using the function ilog for if I want to see all the values, and I'm taking the consideration of the total values of that particular column. That is why I'm using this double dot. And this is the hours is basically for the 0th column. The score is particularly the first, the next column, that is the first column. So this is 0, this is 1, this is 0, this is 1. That is why I'm writing over here the next for the next column. This is if this is a 0th column, then this is a 1 column. So 1 dot values, and I'm using the value of y, that is the target variable, and the value of the target variables. These are basically the values of the target variable. These are basically the values of the predictor variable, which was imported from the data frame into this Google Colab environment. And we understood this thing.
Yes, sir.
So here also we are converting all the observation of the data frame into a NumPy array. Now there uh, for machine learning there are two kinds of set. One is called the training set, another is test set. The training set is used for building the model, and test set is used to evaluate the model or validating the model. In the machine learning, want to create the model, right? So training set is helpful for building the model, and test set is used for which are helpful for going to apply the model, right? We are want to make an automated system. If it is for an automated system, and we are expecting something from that automated system, and we will also calculate that whether that particular system is that output of that particular system is near to the actual value or not, right? So that is why we are using, for building the model, we are using the training set, and for evaluating the model, that is for evaluating the model means that is for evaluating the algorithm which I am using over here, that is the linear regression algorithm, that is whether that algorithm should be tested, and that is why I am using the test set. So in concise, I can say that training set is used for building the model, and test set is used for to evaluate the model or validating the model. So we will write the code from sklearn dot model selection code import test x code test. is equal to test split x comma comma test size equal to 0.2 comma random C. Yes. So similarly, y underscore tray. Now from sklearn.model, right? So sklearn is basically a library where I'm using a model selection, right? Dot model. I'm going to build a model. So I'm using a model selection import. I'm importing a library that is train underscore test underscore split. I'm splitting the model and splitting the data into training set and test set. For building the model, I'm using from the xtrain, and from I'm used for building the model. I'm using training set, and for evaluating the model, I'm using test set. So from the xtrain, that is from the predictor variable, for building the model, I'm using this xtrain x underscore. For building the model, I'm using this train, and for testing the data from the x set, from the x column, I'm also using testing, that is my evaluating the model. Similarly, from the target variable, I'm using some data for training set, and for testing it, I'm using the test set. That is why I'm writing over here x For building the model, I am writing x underscore train and x underscore test, and for training, for building the model, and for evaluating the model from the x column. And again, for building the model, I'm using train from y column, and for testing the model, I'm using test set from the y column, use which is equal to, since I'm splitting the whole data that into training and testing, therefore I'm using is equal to train underscore test underscore split, and I'm passing the value of x and y as for both for training and testing, and test size I'm taking 20% and 80% is for the building the model, that is for training the model. That is why I'm writing test size is equal to 0.2, and for stabilizing the model, to stabilize the model that I want to build, to stabilize my algorithm, I am using this random state property, which is equal to, by default it is always equal to 0. So for stabilizing the model, for stability, I'm using this random state. That is why, and this random state is by default is for stability. If this model is stable, then I am using the random state value is equal to 0. If it is unstable, then the random state value will be 1. But since I want a stable model, that is why I am using random state equal to 0 for the stabilization of the model, right? So since the 80% of the data is used for building the model, so x train from the x train for building the model, that is for the x column, the numpy array 80% of the data is used for building the model, and for the y column, the 80% of the data is used for building the column, building the model from the y column. So how I can recognize it? So in that case, so x train x underscore train dot shape a shape function 20. How many data are over here? 26. The 20 data are used for building the model. Right. Similarly, for y train, y underscore train dot shape is also for out of 26, the 80% of the data are used for the for testing the model. X dot test for y. So for testing the model, this is here. These are the remaining data which is used for testing the model. So if I want to see the dimension, how many data are used for testing the model. So for that dimension, I will write x underscore test dot the shape function. So we will see only 5 data are used for testing the model. Similarly for y underscore test okay, 5 data are used for testing the model. So is it clear? Yes.
Yes, sir.
Yes, sir.
We create now a regression model. So from the scalar dot linear model import linear regression. Model equal to linear regression model is created. Oh, I have to fit the model into linear regression, right? So here, since both the training set and the test set are of same dimension, right? Here training set, for X training set, the dimension is 20. For Y training set, the dimension is 20. And for test set 2, for X test set, the dimension is 5. And the Y set, the dimension is 5. So it can be easily fitted, the model can be easily fitted into the linear regression. But if the dimension is dissimilar, that is, if the X training has 20 but Y train has 15, Similarly, for X test is 5 and the Y test is 3. So that if the dimension is dissimilar, then I have to reshape it again. I have to reshape and then I have to again I have to reshape and then I have to shape it again. Right. So after that, I have to make the reshape the dimension and make it equal. After that, I will create the model. Before that, I cannot able to create that particular model. Right. So if the dimension is dissimilar, then I will reshape it again. I will reshape to make the dimension of both X train and Y train for training set, both X train and Y train to make it equal. And for the test set too, I have to make the X test and Y test also equal. After that, I will create the linear regression model and then I will fit that model into the linear regression model. So since here the dimension are similar to each other, so we can easily fit that model into the linear regression. Right. So the data set that the model means, that is the data set can be easily fitted into the linear regression. Right. So for fitting the model, I am using model dot fit x x underscore train comma y underscore train true, or intercept equal to any, so equal to none. Normalize equal tree 1 would be tree model dot dot set. Okay, just underscore
अरे यार
train
ये क्या है?
dot
ये
shaping the model
लाली
minus one
लाली
one
उस रूम से मेरा ये फोन दे देना
single y underscore train dot reshape. So the thing is that here, when I want to fit the model, I have to reshape the model. If I don't reshape the model for both the training and test set, I cannot able to fit the model. So that is why the error is coming. So I am reshaping the model, right? So in that case, that I'm reshaping the X train and the Y train, right? So similarly, for the test set, since sorry, what X train and Y train is used for building the model. In order to, and I want to fit that particular model into the linear regression. So I will reshape only the training part, not the test part. Test part is for there's nothing needed for reshaping. So for building the model, in order to build the model, I will reshape this training part. So that is why I am reshaping this model, right? And so now I will fit the model into the linear regression. So this one is understood. You understood this thing?
Yes, sir.
Yes, sir.
Okay. So in tomorrow, whether you will be available?
Yes, sir.
Yes, sir.
Yes.
9.
Yes, sir.
So for you just you can take the screenshot of all these things, or I think you will get the video. So we will from tomorrow we will continue after this. That is for fitting the model and then for evaluating the model. And the linear regression. After that, we will move to the multiple linear regression tomorrow, right?
Yes, sir.
Yes, sir.
Sir, can you provide this Excel file?
Yes, I will provide it.
Yes.
Okay, thank you.